So what is electricity? Well, electricity is just a form of energy that is easily transformed into other types of energy to be able to do work. Can you remember the structure of the atom? What's in the nucleus of the atom? We've got two structures here, or two subatomic particles in the nucleus of the atom. And then we have the other subatomic particle whizzing around the outside in shells. Well, inside the middle of the atom in the nucleus, we have protons and we have neutrons. And then on the outside, we have electrons. Now, can you remember the electric charge that each of these has? Protons have a positive charge, neutrons have no charge, they're neutral, and electrons have a negative charge. Now, the thing with these electrons is that because they're in these outer shells, they can sometimes transfer over to another atom. So when an atom gains or loses electrons, it's then called an ion. Ions can be positive if they've donated electrons, and they'll be negative if they gain electrons. Now, that understanding is important for us to think about static electricity. So static electricity is when, say for example, you're walking along carpet and your shoes are rubbing on the carpet, and then you go and touch something metal and you get that arc or that jumping of electricity across to that metal surface, and you get a bit of a tingle and you hear a snapping sort of sound and you see light. So that electrical energy is being transferred to light, heat possibly, well definitely, heat, light and sound energy. So how does it happen? Well, it's when two surfaces rub together. So we have two surfaces that rub together, and electrons from one of the surfaces transfer over to the other one. So we have some of the electrons that go across to the other surface. So this surface here becomes more negative. It's more negative on this side and it's more positive on this side. So if we were just to leave that for a period of time, the electrons will slowly move back over and it'll neutralize. But what happens in static electricity is that when these surfaces come close enough, well, the electron's going to try very hard to get back as quick as they can. So they create this electric shock to actually jump the gap and shoot those electrons back over to this other surface. So other places you see static electricity are in clouds, in thunderstorms, where the clouds are moving and that's causing the electrons to rub off on some of the clouds and not the others. So we've got that difference between the charge from one cloud to the other. And sometimes you get a bolt of lightning from one cloud to the other to move those electrons back, or maybe a bolt of lightning down to the ground. So static electricity, for example, in lightning is very, very powerful, but it can't really be used and harnessed for us in terms of transferring electrical energy into useful work. So for that we need current electricity.